All right, so the next example we have f of x equals, we'll do e to the x plus e to the negative x all over 2. So now, like I said, now that we have the gist of this, we have the idea, we're just going to speed this up a little bit here. So the derivative is going to equal e to the x minus e to the negative x all over 2. And this will equal 0, so let's set it equal to 0. And we're going to go ahead and try to solve for x here. So multiply both sides by 2. And that's going to give me 0 equals e to the x minus e to the negative x. Then I'm going to add e to the negative x to both sides. So I get e to the negative x equals e to the x. Now, a long time ago, you would have learned a property that says if a to the x equals a to the y, then x equals y. You would have learned that in, I forget what chapter. Obviously, books are different, but it would be in the chapter involving exponential functions and logarithmic functions. So if you notice with our example here, we have e to the negative x equals e to the x. The bases are the same, which means the exponents have to be equal. And the only time that negative x equals positive x is when x equals 0. So 0 is going to be our critical point here. So our critical point occurs when x equals 0. Okay? And that's basically how to find critical points. You take the derivative, set it equal to 0, solve. So I can just sum up everything here with, to find critical points, or better yet, to find, let me say it like this, to find where critical points occur. Step 1, find your derivative. Step 2, set derivative equal to 0. Step 3 is solve for the variable. And these steps will give you the critical value slash where the critical point occurs. Okay? If they're asking for the specific critical point itself, so to find a critical point on the graph, use the critical value in the original function. All right. So now what we're going to do is we're going to take this idea of absolute max and mins along with the local max and mins and how do we find these critical values and everything. And we're just going to do a couple examples on actually determining all this stuff. So the directions determine the location and the value of the absolute extreme values of f on the given interval, provided they exist. So the first example I want to do here, very simple one. F of x equals x squared minus 10 on the interval -2, 3. So this is where, and I'm going to go back to our notes real quick. This is where we're going to actually use this procedure. So 1, we're going to find the critical points in the open interval. 2, we're going to evaluate f at the critical points and at the end points. We're going to create a little table. And then 3, we're just going to label things. That's it. So first, our derivative is going to be 2x. All right. Now we set this equal to 0. We solve for x. All right. So here's my critical value. All right. Now we're going to go ahead and we're going to create that little table. All right. So I have x. I have f of x. And I'm going to use my endpoints along with the critical value that I found. And I'll put them in order. So -2, 0, and 3. And what I'm going to have to do is evaluate my function at all these different x values. So off to the right here, f of -2 is going to equal x squared minus 10. And we could use a calculator for this, but I don't think we really have to. So when f is -2, f of -2 is going to be -2 squared minus 10. So that's going to be 4 minus 10 or -6. All right, so there's the first value. Now I'm just going to erase. I'll erase this too. We know what it is. Make my next substitution. So that's going to be f of 0. So f of 0 equals -10. And then lastly, let's evaluate f of 3. So f of 3 is going to equal 9 minus 10, which is -1. So, sorry about that. You're going to look at this, and if we go back to the notes just one more time, we're going to choose the largest and smallest values of f from step 2 for the absolute max and the absolute mins, respectively. So my largest value is going to be -1. My smallest value is going to be -10. And that means that at the point 3, -1, I have my absolute max. And at the point 0, -10, I'm going to have my absolute min. And excuse me, that's it. Like that's as, I don't want to say that's as hard as this gets, but that's the technique behind it. Remember, calculus is all about algebra and techniques. So you got to make sure that your algebra is on par with everything else. If you notice, I'm going to zoom out here just a little bit. From there to there, this step where I just put a little star, that's the only calculus step I did. Everything else was algebra. All right? Let's go ahead. Let's try another one here. Let's do another one. So how about f of x equals x to the 4th minus 4x to the 3rd plus 4x squared. And the interval is going to be -1 to 3. All right. So once again, we find our derivative. 4x to the 3rd minus 12x squared plus 8x. Excuse me. And we set this equal to 0. And the fun part, it's all algebra from here. So setting it equals 0, let's see, I could factor out a 4x. So that's going to leave me with x squared minus 3x plus 2. Now I can factor the trinomial inside the parentheses. So I am old school when I factor this. I always copy down the first, I guess the two terms, x and x. I will always copy down the first sign. I know a negative times a negative is going to equal a positive. And the factors of 2 are 1 and 2. And it doesn't matter where they go because they're both negative. And since they're both negative, they also combine to give me -3, which is great. So from here, I set each factor that contains a variable equal to 0. and I solve. So for the first factor, x equals 0. For the second factor, x equals 1. For the third factor, x equals 2. And these are my critical values. I also have an interval. So let's go ahead, let's create our table. Now, just so you remember, our interval was from -1 to 3. So I'm going to go ahead and just put this all in order. So let's see here. We got -1, 0, 1, 2, and 3. And what you're going to have to do, I'm just writing down the function again. You are going to have to evaluate every single one of these what we call critical values to determine what the outputs are so we could figure out what's the absolute max and absolute min. Easiest way to do this, you got a calculator, go ahead and use it. You might as well. So I'm going to type in, I'm going to click on the y equals button. Let me move this over here. Let's type in our function, x to the 4th minus 4x to the 3rd plus 4x to the 2nd. Now, I don't know if you've ever used a calculator like this before, but directly above the graph button in blue, it's kind of hard to see, but it says table. So what I'm going to do is I'm going to go ahead and select second graph, which is going to give me the table. And as you can see here, it gives me all the values that I need. So when x is -1, y is 9. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 0. And then when x is 3, y is 9. So I'm going to go ahead and just kind of write those in. And I'm going to have to do this so I could still see it. So let me see if this will let me do it. Ah, there we go. So -1, 9, 0, 0, 1, 1, 2, 0, and 3, 9. Perfect. Now what we have to do is just follow directions. The lowest output is going to be my absolute max, and the highest output is going to be my absolute min. And if you could see in this situation here, excuse me, we're going to have an absolute max of 9 at x equals 3 and x equals -1. So absolute max. And then at 0, x equals 0 and x equals 2, that is where we're going to have our absolute mins. And just because I can, this is going to be a local something. So let's see what it is. Take a guess. All right? So if you guess correctly, when you graph it, you're going to be able to see that, excuse me, at x equals 1, you got a local max. Perfect. All right, let's do one more. We'll do one more like this. Let's see. I haven't done any trig ones yet, so let's do a trig. So how about f of x equals sine of 3x on -pi/4 comma pi/3. Okay? So our derivative, now this is a chain rule, so it's going to be cosine of 3x times the derivative of the argument, which is 3. And I'm going to set this equal to 0. So 0 equals, excuse me, 3 cosine 3x. Now from here, I'm going to go ahead and divide both sides by 3, which gives me 0 equals cosine of 3x. Now, from here, you gotta remember your unit circle. So let me go ahead. Let me find us a unit circle real quick. All right. We'll just go to images. And I think that, yeah, this one's pretty nice. Unit circles in standard position. Perfect. All right, so here it is right here, all nice and clean and blue. So remember, on the unit circle, every point is cosine theta, sine theta. So for example, right here at 0 degrees, or 0 degrees, you have cosine of 0 is 1, sine of 0 is 0. At pi over 6, cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is going to be 1/2. But we're looking for, where does the cosine equal 0 here? So the cosine equals 0 at pi over 2 and 3 pi over 2. And if you think about the unit circle, it's going to spin around and around and around. So it's all those different intervals of pi over 2. So what I'm going to do here, in our example, if we get back to it real fast, I think it's time for a new computer because it's just like it doesn't want to work. So there it is. So here's what we need to think. So 3x is going to equal 0 when we're at negative pi over 2 or pi over 2 or 3 pi over 2. And you just keep, doing your unit circle around and around and around. Now, if you think about this, if 3 times x is going to equal all these values when the cosine is 0, all you have to do is just divide all of these by 3. So x is going to equal negative pi over 6, pi over 6, pi over 2, and so forth. Okay? Now, we have a closed interval here. And if you recall, our interval is negative pi over 4 to pi over 3. So our interval is negative pi over 4 to pi over 3. Therefore, our critical values are negative pi over 6 and pi over 6. Anything, so it's only these two right here in the middle. Anything to the left or anything to the right are going to be outside of the interval that I want. So x is going to be negative pi over 4, negative pi over 6, pi over 6, and then pi over 3. Okay, from here, we're going to use these values and substitute them into the original function. To help us, we're going to use our calculator. So here's our calculator. I'm going to type in negative pi over 4. And I'm going to store that in for x. And then I'm going to type in our function. So remember the original function. Let me scroll up here. Was sine 3x. So sine 3x is going to be negative 0.707. So I'm just going to write that in. So negative 0.707. And I'm going to just repeat that process for all my other x values. So let me just get my calculator up here. All right, so the next one is going to be negative pi over 6. Store an x. All right, and then second enter. Second enter. And that's going to give me negative 1. Now, just keep going. Pi over 6. Store in x. And then second enter, second enter. That's going to be positive 1. And then lastly, pi over 3. So pi over 3, store in x. All right, and then we're just going to do second enter, second enter. So the sign of 3 times pi over 3 is going to be 0. All right, perfect. From here, we look for the absolute max and the absolute min. So our absolute min is going to be at negative pi over 6. And then the absolute max occurs at positive pi over 6. And that's it. So the last thing we're going to do here is going to be an application problem. The problem I have for us is just a simple box problem. So I'll just go ahead and read it. All boxes with a square base and a volume of 50 cubic feet have a surface area given by the equation S of x equals 2x squared plus 200 divided by x, where x is the length of the sides of the base. Find the absolute minimum of the surface area function on 0 to infinity, so on the interval 0 to infinity. And then what are the dimensions of the box with minimum surface area? So they want to figure out first, let's find the absolute min of the surface area function, and then what are the dimensions of this box? So for this problem right here, and this is just from now on, anytime you hear the words minimum or maximum, you should be thinking derivative. So we're going to take the derivative. So let me go ahead and just write out the function again. All right, so here's our surface area function. And before I even do that, I already see something that's not bothering me, but I know I'm going to have to take care of it. Remember, you got a variable in your denominator, rewrite it as a negative exponent. So from here, what I can do is go ahead and take the derivative. So I get s prime of x equals 4x minus 200x to the negative 2. Now, I'll just clean this up a little bit. This is going to be 4x minus 200 over x squared. And then finally, if I just want to just create one fraction and not have two separate ones, find a common denominator. It's going to be x squared. So this is going to equal 4x cubed minus 200 all over x squared. So this represents my minimum surface area function. Okay? Now, the second part of this problem was, all right, well, if you can find the minimum surface area function, tell us what that is. What are the dimensions of the box? So in order for us to do that, we need to find a critical value. We need to find when does the derivative equal 0? Because remember, at critical values, you're going to have either an absolute max or an absolute min. In this case, we're going to have an absolute min. So to solve this, you got to be careful. We know x cannot equal 0, so I might as well just go ahead and just say that right now, because you can't have a 0 in your denominator. So basically, this is going to equal 0 when the numerator equals 0. So I'm just going to go ahead and just solve this, add 200 to both sides, divide both sides by 4. You get 50 equals x to the third, or the cubic root of 50 equals x. And since this is a box with a, this is a box with a square base, and they told us the volume, the dimensions of the box will be the cube root of 50 by the cube root of 50 by the cube root of 50. Nobody said these numbers had to be nice and pretty like they were in algebra class. All right? But the length, width, and height are all going to be the cube root of 50. So I hope this helps, and I'm going to go ahead and start working on the next video, which is in section 3. Talk to you soon.